Hello, friends. So, in continuation with previous video, there's 2003 questions related to construction of an embankment, and the problem is like this. It is of 15 marks. So, the conventional examination question is like this: Earth is required to be excavated from borrow pits for building an embankment of height 6 meter, top width 2 meter, and side slopes 1 is to 1. So if you look to the solution of this problem, so earth is required to be constructed for an embankment. The height of the embankment is given to you as 6 meter, and the top width 2 meter, and the side slope is 1 vertical, 1 horizontal, 1 is to 1. The unit weight of undisturbed soil in the wet condition is 18 kilonewton per cubic meter, and the natural moisture content is 8%. So undisturbed soil, so you have got undisturbed soil here. This is undisturbed soil, and its unit weight is given. So gamma moist is given to you as 18 kilonewton per cubic meter, and the natural moisture content is given to you as 8%. So 8%, that is 8 divided by 100, 8%. So 0.08. The dry unit weight required in the embankment. So the dry unit weight for this embankment, the embankment and the undisturbed soil. So this is the first part, number 1, and the undisturbed soil mass, this is the second part. So here the dry unit weight gamma d1 of this embankment part is given to you as 20 kilonewton per cubic meter, and the natural moisture content is 10%, that is 0.1. And the unit weight of soil solids is known to us, 2.7. We have to estimate the quantity of earth required to be excavated in the borrow area to construct 1 meter length. So 1 meter perpendicular to the board, 1 meter length of the embankment. So estimate the quantity of earth. So what is the volume of earth? V2, so that you can construct this embankment of length 1 meter, right? So this is the first part of this question. Estimate the quantity of earth required to be excavated from the borrow area. That is V2. Let V2 is the quantity of earth required to be excavated from the undisturbed soil mass, which is the borrow area, so that you can construct the whole embankment like this, right? So here you can very well find out the uh, V2. Here you can find out the volume V1. So let the volume of the embankment is going to be V1. So you can find it out, the volume of the embankment. Here it is 2 meter. So this becomes 2 meter, and the height is 6 meter, and the slope is one vertical, one horizontal. So this becomes 6 meter, and this side also it becomes 6 meter. So bottom total it becomes 14 meter, 1/4. So the area will be 2 plus this is 14. You take the average divided by 2, right? And multiplied by the height, that becomes the area. And if you multiply it by 1, that is 1 meter length, that becomes the volume of the this one. So V1 you can calculate it. So volume of the embankment V1 is the volume of embankment, and this we can calculate it. This become 8 multiplied by 6. This becomes 48 meter cube. Now here V2 you will have to find out. So quantity of earth required to be excavated is V2, and we can write that V2 divided by 1 plus E2 equal to, if you consider this soil mass, which is made of soil solids and the voids, and the total volume which you are going to excavate from here is going to be the void, and there is going to be the volume of soil solids, and the total volume is going to be V2. This V2 can be written as 1 plus E2. So V2 divided by 1 plus E2 must be written as the volume of the embankment, that is V1 divided by 1 plus E1. So what is the E1 here? That we can always calculate. Here gamma D1 is known to you. So E1 will be G gamma W upon gamma D1 minus 1. So if we calculate, E is given over here as G is given as 2.7. So let's calculate it. Gamma W 9.81 divided by gamma D1 is 20 minus 1. So E1 comes out to be 0.3243. This is the value of E1. Similarly, you can calculate for undisturbed borough area, you can find out the value of E2 will be G gamma W upon gamma D2 minus 1. Now gamma moist is given to you. So gamma moist, gamma D2 will be this gamma M divided by 1.08 divided by 1 plus Wn. So 18 divided by 1.08 is 16.66 kilonewton per meter cube. So gamma D2 is calculated. So if you calculate G equal to 2.7 into 9.81 divided by 16.66, this is 0.5892. So this is the value of E2 for the borough area. So now to find out the V2, E2 is known, V1 is known, E1 is known. Therefore, V2 will be 1 plus E2 divided by 1 plus E1 multiplied by V1. So V1 is already known, 1 plus E2. So let's calculate this. 1.5892 divided by 1 plus E1 3243 multiplied by 48. This gives you 57.604 meter cube. This is the answer of this part. So we have been able to estimate the quantity of earth required to be excavated from the borough area to construct 1 meter length of the embankment. This is V2. So this part has been calculated and this is the answer. Now go to the next part. If each truck has a capacity to carry 80 kilonewton per trip, what is the number of truckloads required per meter length of the embankment? So number of trips you are going to, in each trip you are going to carry 80 kilonewton. So each truck is to carry 80 kilonewton. And what is the volume of the soil? This much. Therefore, the weight of soil is going to be V2 multiplied by the moist unit weight. The moist unit weight is already known to you. So that becomes the weight. So 57.604 670 multiplied by 18. This comes out to be 1036.88 kilonewton. So the total weight. Now the number of truck loads required. Therefore, number of truck load required will be this, the weight of the soil, that is 1036.88 divided by it is going to carry in each trip only 80 kilonewtons. So divided by 80. So if I divide it by 80, the 12.96, that is 13 trips, 13 truckloads required for constructing um, the embankment. So this embankment, for this number of truckloads required will be, so in 13 trips you will be able to carry the total weight of the soil, which is 1036.88 kilonewton. Now, in the next part is going to be, so this is the another answer. This is the another answer. Now, the third part is what are the values of porosity and degree of saturation for the embankment. So, what is the porosity? Already E1 is known to us. Therefore, the porosity N1 can be easily calculated. So, let's calculate. We know that the porosity N is volume of void to total volume, and it is expressed in percentage. Volume of void is going to be E1, total volume is going to be 1 plus E1 multiplied by 100. So E1 is already known, so 1.3243 divided by 1.3243. There is 24.48. So this gives you 24.48%. This is the answer for the porosity. So this answer is, now SR means degree of saturation. Now also calculate the degree of saturation. So degree of saturation equal to, already you know the moisture content. So Wn into G divided by E1. So in this part, E into SR equal to W into Z. So what is the value of Wn? Wn is the unit weight, the dry unit weight required in the embankment. Wn is 10%. So it is going to be 10% into G divided by E1. So degree of saturation, if you calculate it, so it becomes 0.27 divided by 0.323, 83.256%. So it is degree of saturation is 0.8325, that is 83.25%. So the degree of saturation is 83.25%. So this is the complete solution of the problem. This was of 15 marks in the mains examination. So lot of marks have been awarded for this particular question. And in 2023, similar question has been asked. So let us see the next problem that we will see the next problem now. The next problem is like this. I hope you have understood it. I have tried my level best to make it as brief as it could be, so that in the examination you are able to save your time. Now, the 2023, this is of 12 marks question. An embankment is to be constructed using sandy clay compacted compacted to dry density gamma d equal to 18 kilonewton per cubic meter. So you are going to use sandy clay and it is compacted, achieving a dry density or dry unit weight of 18 kilonewton per cubic meter. The sandy clay is transported to the site. The sandy clay is transported to the site from a borrow pit. Uh, from the borrow pit. The bulk unit weight of the sandy clay In the borrow pit, in the borrow pit is 16 kilonewton per cubic meter, and its natural moisture content, water content is 11%. Calculate the volume of sandy clay from borrow pit required for 1 meter cube of finished embankment. Assume soil swells by 10% due to excavation during during transportation. Take value of a specific gravity of soil solids equal to 2.7. So you have to have an embankment to be constructed using sandy clay. So you are going to have an embankment. This is the embankment, and it's you are going to use sandy clay and compacted to gamma D equal to 18 kilonewton per cubic meter. This is compacted, this sandy clay. So this is the embankment. So let's see the solution. Gamma D is given to you, and this is the first part. So we can say gamma D1. And the sandy clay is transported. So it is transported to the site from the borrow pit. So you have got borrow pit, and from the borrow pit it is transported, and the bulk unit weight here, or the moist unit weight, is given to you as 16 kilonewton per cubic meter, and the corresponding moisture content of this borrow pit is 11%. So we need to calculate the volume of the sandy clay from borrow pit required for 1 cubic. So let's say let volume of sandy clay or volume of soil from borrow pit equal to V2. So V2, and here let's say the volume of the embankment is V1. This is the volume of embankment. So uh, the this we have to find it out. So what is the relationship between V1 and V2? We know that V1 upon 1 plus E1 equal to the volume V2 divided by 1 plus E2. So V1 is already given to us. It is 1 cubic meter. So this is known. And E1 can be easily calculated. Let us calculate. E1 equal to G gamma W upon gamma D1 minus 1. So calculate this. And here gamma moist is known to us. So gamma D2, the dry unit weight, will be gamma M divided by 1 plus W NN. So this we can calculate it in kilonewton per cubic meter. Therefore, E2 we can calculate as G gamma W upon gamma D2 minus 1. So this also we can calculate it. And therefore, we will be able to calculate V2. So I will calculate 2.7. Point 4715. And this one will be 16 divided by 1.11. 14.4144 kilonewton per cubic meter. So 2.7 into 9.81 divided by, so this becomes 0.8375. Therefore, V2, that is the volume of soil from borrow pit, is going to be 1 plus E2 divided by 1 plus E1 into V1. So let us calculate this. 1 plus E2 divided by and 1 plus E1. So V2 equal to 1.24875 cubic meter. And this is the volume of soil from borrow pit. But the next part, for 1 cubic meter of finished embankment, assume soil swells by 10% due to excavation and during transportation. So the swelling factor is also given. 10% means it becomes 1.1. So therefore, the volume required from for this embankment, uh, that is for 1 meter cube uh, of finished embankment, so will be swelling factor multiplied by V2. So the final volume required at the site for 1 cubic meter will be 1.1 swelling factor multiplied by V2. So it becomes 1.37336 meter cube. So when you bring this for finished embankment, the volume required will be this much. To construct the volume of embankment of 1 meter cube. So this was of 12 marks question. Friends, I have been able to calculate 2023 and 2003 question paper. I will also like to cover up the relevant theory related to the soil properties. And if I find few more questions, that also I will be doing shortly in my next video. Thank you very much.